Hello everyone, and welcome to today's chem lesson. Today we're going to keep going, continuing our discussion that we started the other day on elements and compounds, and move forward and talk about the difference between a pure substance and a mixture. Now, everything that we mentioned before, all of those elements, all of those compounds, are what we call pure substances. There is only one type of matter in a pure substance. If I have this iron bar, right, or iron cube, it is entirely iron, top to bottom, left to right. There is no other type of matter in here other than this elemental iron. If I have this cup of water, and I say this is a pure cup of water, that means there's nothing in here other than H2O. There is no other substance in here other than water. A pure substance is either an element or a compound, but it is only that element or compound. There's nothing else in there, nothing else with it. Now, if we take two types of matter, two pure substances, and mix them together, we have created a mixture, right? A blend of two or more kinds of matter. The thing to note, and the thing we're going to come back to, is that each piece retains its properties. Right? That means when you make a mixture, you're not making a new thing with new properties. You're taking two things that have different properties and putting them together where they both keep their properties. And there are two types of mixtures. Right? The first is a heterogeneous mixture, a non-uniform mixture, while the second is a homogeneous mixture, which is uniform. Now, what do I mean by non-uniform? Also, why did I just write chocolate chip ice cream here? Right, let's talk that through. Our first example of a non-uniform mixture is a cone of chocolate chip ice cream. Right? In this scoop of ice cream, there are a bunch of chocolate chips. This ice cream scoop, right, ignoring the cone for now, but this ice cream scoop contains two types of matter. It contains chocolate chip, and it contains vanilla ice cream. Every sample, right, in our case, every bite of ice cream that we take is not the same. Some bites have no chocolate chips in them. Some bites have multiple chocolate chips in them. Some bites have 1 or 3 or 2 or 6 or none. Or sometimes you get half a chocolate chip. Right? It's not uniform. Even if you take the same size bite every time, you're not going to get the same amount of ice cream and a chocolate chip every time. Right? It is not uniformly mixed together. Every sample is not the same. Meanwhile, in something like salt water, if you have a container of salt water, no matter where you take your sample, every sample of salt water is the same amount of salt and water. Right? Whether you take a sample from the top or the bottom or the left or the right or the middle, right? No matter where you take your samples from, a uniform mixture is the same top to bottom, left to right, front to back. Now, what if we had something like the air, right? You breathe in, you breathe out. You breathe in, you breathe out. Is that air that you are breathing in and out a pure substance, a homogeneous mixture, or a heterogeneous mixture? Not counting pollution, right? We're not talking about there's dust in the air or there's smog or smoke, right? Just the air. All right. The correct answer here is choice 2. Air is not a pure substance. Think about it. What do you breathe in? What's the point of breathing in? What are you trying to get out of the air? Oxygen. And when you breathe out, you're breathing out carbon dioxide. So already, that's 2 substances in the air. Not to mention the other gases that are in there, right? It's not just oxygen and CO2. There's nitrogen, there's argon, there's helium, there's hydrogen, there's all sorts of gases in the air. Right? So it's not a pure substance. Which brings us to mixtures. We know it's a homogeneous mixture because the air that you breathe in and out doesn't change when you move from room to room. If I go to the kitchen and take a breath, there's no more oxygen in the kitchen than there is in the bathroom or in the bedroom. Right? No matter which room in my apartment I'm in, the air is the same. Right? I don't have to go to the kitchen to get the oxygen and then come back here to teach and then get up and leave and go get more oxygen from the kitchen. And it's not separated, it's not unevenly distributed. It's all evenly distributed. You're breathing the same ratio of oxygen, carbon, nitrogen, argon, all the rest, as I am. Right? We're in very different places. What about this one? Which one of these is a heterogeneous mixture? Which one of these is unevenly distributed? Here our answer is choice 1. Soil is made up of a bunch of different things. Soil is actually, of the 4 choices, the only one that is a mixture. And on top of that, if you take 2 different soil samples from even 10 feet apart, they will have different stuff in them, right? Different seeds, different rocks, different dirt, different leaves, different everything. Sugar, carbon monoxide, and carbon dioxide are all pure substances. They are all also compounds, right? But we could also add, oxygen or iron to that list as well. Right? But if I say, here's a bowl of sugar, there should be nothing in there other than sugar. Right? These things, by calling them by their compound names, you know that they are pure substances. Now we also want to talk about what we can do to separate mixtures. Right? Mixtures are these things we've taken two different things and put them in the same container. Can I go and get them out? Can I get back my two separate things? Yes, I totally can. I can undo the mixing that I did because these substances are only physically mixed together. There is no chemical reaction happening. You mix them together physically, you can unmix them physically. And there are a couple of different ways that this can happen. The two important ones that we're going to talk about and define are filtration and distillation. But there are also a bunch of other ways. Right? Filtration, first, is separating a mixture based on size of the particles. Right? This is using filter paper. Right? Meaning you make coffee using a coffee maker. The grounds get caught in the coffee filter, but the coffee drips into your mug so that you can go about your day drinking your coffee, right? You don't have a bunch of coffee grounds in your coffee. They're bigger than the liquid, they're bigger than the coffee. They get caught in the filter. Right? Same thing if I have a bucket of sandy water on the beach. I pour my sandy water through the filter. The sand gets caught by the filter. The liquid comes through. So my salt water comes through. I've separated the sand from my salt water. This is the same thing as going to the bank and using the coin machine. Right? The coin machine separates all of your coins based on size. It catches the bigger ones first, then it catches the ones that are a little smaller, and all of the small stuff falls through. Right? So you pour in all your coins from the top, your big old jar of coins. The quarters get caught, then the nickels get caught, pennies and dimes fall through. Right? Then the pennies get caught, then the dimes get caught. And it counts them up based on size, right? Quarters are the biggest, so the holes in the first tray are smaller than a quarter. So the quarters can't get through them. Then the same thing here. The nickels get caught here, and there's slightly smaller holes. Then the pennies get caught, or then the dimes get caught. Right? Filtration doesn't have to be with a filter paper, right? It can be anything that separates these things based on size. The second method that we're going to talk about is distillation, which is separating specifically multiple liquids. Based on boiling point. This is really useful when we are making alcohol, and so if you go to a distillery or you go to a brewery and you take a tour, they'll walk you past these big giant machines and these big giant drums that are all doing this process, right? They are taking the liquid that you have, right, some combination of two liquids. When they heat it up, one liquid boils first because it has a lower boiling point. Right? One of these liquids boils, slowly leaving. Right? Now you only have your second liquid. And this liquid either gets caught, right? They can catch it and cool it down and let it come out into a separate container. Or they can let it go away, depending on whether or not it's useful. right? But you've taken what was A plus B and separated it, right? Because A boils sooner, it has a lower boiling point, it evaporates and then either gets recondensed or leaves. On top of that, there's a bunch of other ways that we can separate mixtures. If you go to a restaurant and they serve you a salad with onions and you don't like onions, you can just pick out the onions, right? You can see the difference between the onion and the lettuce and the tomato, and you can just pull out the onions, right? Just using what they look like, right? Using their size, shape, texture. You can also separate things based on physical properties. If you have a bunch of magnetic iron in a beaker full of sand, a big magnet will take all of the iron out and leave you with just sand. Right? You can separate things based on their physical properties. If you have a bunch of ping pong balls and golf balls that you can't tell the difference between. Ping pong balls float, golf balls don't. Right, so just dumping them into a thing of water, we'll see some of them separate by floating to the top. If you have a combination, right, something dissolved in water, you can boil away the water. Right, if I have salt water and I boil it, the water leaves and the salt gets left behind. And then I've got water vapor and salt separating my mixture. Right, this is why it's important for me to say before that in a mixture both things keep their properties. Right, just because I took magnetic iron and I put it in water doesn't mean that the iron is now no longer magnetic, right? It still keeps its properties as we combine them together, as we mix them. And with that, I'm actually going to transition us back to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.